Hello everyone. Now let's begin with this mathematics for engineers. Firstly, we will be discussing some important topics related to matrices. What is a matrix? It is simply a rectangular arrangement of numbers or variables organized into rows and columns. For example, in this we have 2 cross 3 matrix, that is number of rows are 2 and number of columns are 3. We write rows into columns and this becomes the order of the matrix. So in this particular case, in the given example, the order of the matrix is 2 cross 3. Now moving towards the types of matrices, let us consider or identify the different types of matrices based on their shapes. If the matrix have a single row, I will call it as a row matrix. If it has a single column, I will call it as a column matrix. If the number of rows and the columns become equal, that is, for example, 2 cross 2, 3 cross 3, 4 cross 4, means it is a square matrix. If these are different, means rows and columns are different, it will be called rectangular matrix. If all the entries of a matrix, no matter whatever the order is 0, then we call it as a zero matrix or we call it as a null matrix. Moving further in types of matrices only, when all the non-diagonal elements are equal to 0, we call it as a diagonal matrix. Means only the diagonal entries are non-zero. Now, then if all the diagonal elements becomes equal, we call it as a scalar matrix. If all the diagonal entries becomes equal to 1, we call it as a identity matrix. In upper triangular matrix, below the main diagonal, if all the elements are 0, we call it as upper triangular. And vice versa, we take it in lower triangular matrix. That is, in that matrix, all the elements above the main diagonal will be 0. Okay. Now, moving towards the next concept, that is transpose. Transpose simply means the interchanging of rows and columns. Now, the first row will become first column and the second row will become second column. That is, if in first case I have the order as 2 cross 3, in the second part, the order will be now reversed, that is 3 cross 2. So this is what we called it as a transpose of a matrix. And yes, keep this rule in your mind that taking the transpose twice will give you back the original matrix. That is, transpose of the transpose will give you the original matrix, that is A matrix. So now let's move towards the another part, that is symmetric matrix. If the transpose of the matrix comes out to be the matrix itself, that is the given matrix itself, suppose I have a matrix A, if the transpose of that matrix means A transpose is equal to A itself, then I will call that the given matrix is a symmetric. But if on giving or transposing the matrix, if it comes out to be negative of the matrix, then I will call this concept as a skew-symmetric matrix. Now similarly, we will be moving forward by taking this transpose along with the word conjugate. For matrices which have complex numbers as their elements, we use this concept of conjugate. So if I have a complex number like A plus iota B, its conjugate will be now A minus iota B. Like for example, 2 plus 3 iota, it will be having the conjugate of 2 minus 3 iota, right? So now if we take the conjugate of a matrix and then we take the transpose of a matrix, then we have another word which is called it as a Hermitian type of a matrix. Clear? So moving towards Hermitian matrix, what it says conjugate of the transpose or transpose of the conjugate, whatever way you want to do, will give you the Hermitian matrix. Now moving towards another part, if I get conjugate transpose to be equal to negative of the given matrix, then I will say that this concept is what we called it as a Skew-Hermitian. Like the previous concept in which we have symmetric and skew-symmetric, here we will be having Hermitian and Skew-Hermitian. Wherever you find this word skew, the matrix, given matrix, will be the negative of the matrix. Okay. In the first case, we will be just taking transpose in skew-symmetric, and yes, in Hermitian, we will be taking firstly conjugate and then transpose of that conjugate. So it will give you Skew-Hermitian matrix. So in this video, we have revised all the fundamental concept of matrices. different types of matrices: transpose, conjugate transpose, matrix, skew-symmetric, Hermitian, Skew-Hermitian. So in the next lecture we will be beginning the most or other important lectures of linear algebra, like determinants, minors, and then we will be moving forward.